Another example problem. Uh, Here we have a problem if an operator A is a Hermitian operator, and this set of n kets form an orthonormal basis, show that for an arbitrary state psi, that the expectation value of A squared is equal to this expression over here squared. Basically, the projection of psi onto the basis set with A in between. Yeah. All of these problems in these formal settings always seem more imposing at the start than they really are. They're really pretty easy once you get a mindset to of the notation, really. And this one's really no exception. I just write out what everything is. So I'm going to start over here, and the expectation of A squared for this arbitrary state is I just sandwich A squared, the expectation value between psi. And then A squared, of course, is just A operating on A. And then again, I insert an identity operator. That doesn't change anything. And the form of the identity operator I'll choose is the one that it comes from this complete basis S, this complete orthonormal basis, which are and that identity operator is just the sum over all of these of this Ket-Bra product, outer product. And then you pull the summation outside. The only place there's an n is here. And so you'll get, on the first half, you'll get psi A ket n. And on the back half, you'll get n A ket psi. So you get these two. However, A is Hermitian, and so we know that A is equal to A dagger. Okay? And as a result, I know that I can write this form here as the dagger of this quantity with everything reversed. Okay? So remember, when you take the dagger of it, I would have to reverse the quantities. That becomes psi, A dagger, and n. So it becomes that. And if you look at these, well, these are just anytime you've evaluated this, these are just complex numbers. This is A on psi is some state, and when you bracket it, inner product that with this, you get simply a number. And so the Hermitian conjugate, it should be a complex number. Both of these are complex numbers. Is the Hermitian conjugate is simply on a complex number is just the Hermitian is just the a complex conjugation. And so now then you've got the some number, complex number, and its complex conjugate, same number, complex conjugate, and that's just what we mean by the absolute modulus squared, and that was what we were asked to show. Here.